Welcome back. We are looking at Chapter 5, How Can We Identify Minerals? We're going to take a look at the vocabulary that's given to us. Here it says density, the weight of a substance compared to the weight of another of the same size. So if there's two things that are exactly the same size and shape, exactly the same size and shape, but one is more dense than the other one, then that one's going to weigh more. Luster, shine. Cleavage, the pattern in which a mineral splits, like how it breaks. Streak, the color of a mineral's powder, what it leaves behind when you streak it across a ceramic tile. So we're going to flip to the next page. Make sure that you've got like a highlighter or a different colored pen as we go along. So have you ever heard of fool's gold? It looks like gold, but it is another mineral. It is worth far less than gold. Many people have been fooled by it. So I'm going to show you an example. So here on the left-hand side is pyrite, or which is fool's gold. And here on the right-hand side is what gold looks like. So pyrite has been often mistaken for gold because sometimes they actually have the exact same type of coloring. But when you actually take a look at the way it's structurally built, you can see that pyrite has definite formations within its structure, and in gold it doesn't really have much. I'm going to show you a TikTok video on your teams, so that way you can see what gold hunting is like and how some people are able to identify it so quickly, even though it's teeny tiny. So many minerals have lookalikes. That is why scientists have come up with tests to identify minerals. Sometimes only one test is needed. More often, several are needed. So these are the most important tests that we are going to use to identify types of minerals. So the first one is called hardness. Minerals have different hardnesses. To find out how hard a mineral is, we test it against other minerals. 10 minerals whose hardnesses are known are used for this test. Diamond and talc are two of these minerals. Diamond is the hardest mineral and talc is the softest. Next is density. Density is the weight of a substance compared to its volume. Different minerals have different densities. Color. Some minerals are colorless. Others come in just about any color you can imagine. Luster. The kind of shiny quality a mineral has. It's called its luster. Crystal form. Crystal form is the natural form of some, but not all, minerals. Crystal form helps identify some of these minerals. Cleavage. The way a mineral splits is called cleavage, or the way it breaks. Some minerals split in definite patterns, others do not. Streak. When you rub a mineral on a hard, rough white surface, it may leave a streak of powder. The color of its streak is important. Some minerals leave no streak. Acid test. The mineral calcite is tested with dilute hydrochloric acid. Bubbles are given off if calcite is present. Dilute hydrochloric acid is used to test for the mineral calcite. Now, just to let you know that not all minerals will react to acids. And there are other ways to identify minerals. Other ways are with if it's magnetic. Other ways are the way it smells, the way it tastes. Although I highly do not suggest that you go around and randomly taste minerals or even smell random minerals, because some of them can definitely be poisonous. But these are some of the common ways in order to identify a mineral. So the first way to identify minerals is using the mineral hardness scale. The mineral hardness scale shows the 10 minerals that we test other materials against. When a material is tested for hardness, it is given a number to show how hard it is. A material with a hardness of 2.5 would be harder than gypsum, but softer than calcite. A mineral can scratch something softer, but not something harder. So I'm just going to show you a different scale. So the scale looks like this. Let's make sure it's all in the camera here as best as possible. So I'm just going to show you the first half of the scale. I'm going to make it a little bit bigger. So this is the Mohs hardness scale. That's what it's actually called. So here the very softest material there is talc. And this is what talc looks like in its mineral form. And talc is easily broken apart with just your fingernails. That's how soft it is. Your fingernails are actually harder than talc. Next is gypsum, and it looks like this. We were talking about gypsum in the last lesson, how gypsum is used for within drywall. It's a building material. Next is calcite. It has a different structure. Fluorite, it comes in many different colors and it also has a definite structure. We have apatite, not as an appetite in terms of eating, but apatite in terms of the mineral, and it also has a definite structure. Feldspar, there's lots of different types of feldspar out there, but and it's all in different types of colors as well. Quartz. Quartz, we've seen it before in one of our other lessons, and quartz has a definite structure, and it also comes in many, many different colors. Topaz, this is what it looks like when it's cut and polished into a gemstone. Corundum, corundum is like sapphire, and this is also when it's cut and polished into a gemstone. Corundum is also ruby, just so that you know, ruby and sapphire are in the same gemstone category. And then we've got diamond, which is here, you can barely see it, it's not the greatest picture, but diamond is the hardest material out there known to man. And as a joke, you can see in this particular one is they've got a Nokia phone, meaning that it is the hardest man-made material out here. Nothing can destroy it. Now, just so you know that all of these minerals from this point on, from diamond all the way back to talc, they are not man-made materials. These are right from the earth itself. They can be manipulated by man in order to be used in different forms, absolutely, but they are not man-made materials. So which mineral cannot scratch any mineral but itself? So which one is the absolute hardest? So we would put here that it is diamond. And looking at the scale, which one is harder, calcite or topaz? So we would look, so here we've got topaz and we've got calcite, and we know that topaz, because it's closer to diamond, that way it's going to be harder. So study diagram A and answer these questions. Which weighs more, mineral A or B? So here we have mineral A and we have mineral B. And if you notice, they are the same size and they are the same shape. So which one weighs more? So looking at the scale here, we know that B weighs more. And so the chunks of minerals A and B are of the same size. But mineral B is denser than mineral A. So the materials that's made up inside of it are a lot denser, so they have more weight, more volume, more mass. So here we've got minerals come in many different colors. This is black and white, so this isn't going to help you. So we have graphite, which is black. So if you look at the end of your pencil, that's graphite. Even though we call it pencil lead, it's not made from lead anymore. It's graphite. opal, if you are an October baby, your birthstone is opal, and opal can be in from milky white all the way to black, and it looks like there's flashes of color in it. Absolutely beautiful. Halite is white. It's very has a lot of striations in it, lots of lines in it. Microlite, it's green. I've never seen it. Sulfur is yellow, and sulfur can be a very dangerous type of mineral. Hematite is red, although hematite as well can be black. So there's different types of hematite that's out there, and hematite is quite breakable. And azurite is blue, and it's a very very royal looking type of blue. So if we take a look at this picture here, we've got all different types of minerals in here. And the thing is, we don't know what's what here. These are all tumbled minerals or tumbled rocks, because you can see they all have very nice round edges here. So with these rocks, you would have to try and identify them. So for instance, I can look at some of them. I'm thinking that this clear one is probably a quartz. This one and this one, this is probably a carnelian. This one is probably malachite, something like that. And this is some sort of jasper, and this looks like it's some sort of agate. These are rose quartz. These look like they're citrines. And not saying that you'd be able to identify them right off the bat, but some stones you can, just by the way they look. But like it was said before, some stones look exactly alike to each other. And we'll see some examples of that a little bit later. All right, we're going to go look at the next page. I'm going to make this bigger so we can see the top of it. So here it says luster is divided into two classes. So we have metallic and non-metallic. So again, this is a black and white picture, so you can't exactly determine which one's supposed to be metallic and non-metallic. So, and there are letters here. This is A, this is B, this is C, and this is D. So it says here, minerals that shine like metal have metallic luster, and minerals that do not shine like metal have non-metallic luster. And there are several kinds of non-metallic lusters. So can you identify these lusters? Write the correct letters next to each luster. So here we have A. So this one is a metallic type of luster, I'm assuming. So we're going to say that it is A. B does not have a metallic luster, C definitely does not, and D definitely does. So we're going to take a look at some of these metallic lusters. Got an example here for you, best as we can. So here we've got a metallic luster, so meaning that it looks like metal, and it's shiny, and it's reflective. And that there are some other metals that are kind of like submetal. They're still shiny and sort of reflective. And then the rest are non-metallic, that they're not very shiny. Or they're shiny in their own way, but the thing is that they're not reflective in terms of like a metal, like silver or gold or bronze or copper or anything like that. It has to have that metal type of look to it. So these are the different categories of non-metallic luster. I'm not expecting you to know all these, but I'd like you to at least have an understanding that there are different types out there. So there are many crystal forms. Which one is quartz? And I want you to circle it. So the other day we were looking at quartz and identifying its shape, and it has a very specific type of shape that comes with it. And also I had uploaded a TikTok video for you to take a look at about people who go quartz hunting, and they look deep into these clay mines looking for these pieces of quartz, and sometimes they're quite gigantic. So out of all of these particular shapes, which one is a quartz shape. So I'm going to tell you it's this one right here. So you would circle that one. And then, do all minerals form crystals? No, they don't. So we're going to take a look at some of the quartz crystals, or the crystal systems that are out there. So, and these are just some of them. These aren't all of them. So some form cubes, some form rectangular cubes, and some are a little bit slanted, and it just depends on how they are formed and in which direction that they're formed. And some are just a little off center. They're rectangular type of prisms that they've got going on here. Some have 6 sides, and there's so many more than just what you see here. These are just some examples. What instruments can be used to show the cleavage of minerals? Now remember, cleavage is all about how it breaks and the direction that it breaks. So here they're using like a hammer and even a screwdriver to use as a lever or as a wedge. Because some minerals, they will break off in sheets like this one here. And then some minerals, all they do is break off in chunks, so they don't necessarily have a particular type of cleave. On to the next page. So there are many types of cleavage. So quartz show no definite cleavage pattern, just breaks off. Calcite cleaves in a very definite pattern, meaning that it has a very definite break and it only breaks in one certain direction. And mica cleaves easily in thin, flat sheets. So if you've ever seen mica, you can look it up online, whatever, and you'll see that it comes off in these very thin, transparent sheets, and they're incredibly brittle. Streaking is done by rubbing a mineral on a hard, rough white surface. The streak is the color of the mineral's powder. Some minerals, they don't have a streak. Some minerals streak the same color as the mineral, and some streak a different color than the mineral. So here it's given an example. The mineral quartz leaves no streak. So the mineral iron pyrite is yellow, but it streaks a greenish black, almost more like a gray. Gold, if you streak it, it would streak its own color, because gold is very malleable. Remember, it's very soft. And then here we have like an acid test. So for here we've got acid, diluted hydrochloric acid, and we're dropping it onto calcite. It's going to bubble. Again, not all minerals will react with acid. All right, so now your assignment, you know how to do these things. So we've got our word bank. You're filling in the words. I don't think anything's used more than once on this particular one. Doesn't look like it. Matching, you can draw lines if you want to, or you can just put in the letters. That's fine. True or false. T for true, F for false. And then last part is reaching out. You're answering the question. So it asks here, iron pyrite is sometimes known as fool's gold. If you had a yellow mineral, what would be one test you could use to see if it was real gold or iron pyrite? So this is testing your own knowledge about what you know about gold itself. Maybe you have to do a little bit of digging or a little bit of research in order to find out more about it. All right, so I want you to finish this up, writing this into your booklets. I do want you to check out Teams, because I will have a couple of videos posted for you, one about identifying minerals, so that way you can see some examples, and then also how to go looking for gold, gold panning. So it's really interesting to watch some of these people that do this on TikTok. All right, So I hope you have a good day. If you have any questions, please ask the adults in the classroom. If you're at home and you're struggling with this, please either email me or text me or message me, and I'll try and get back to you. See you soon.